Alaska is such a fun place when it comes to volcanoes, and I love it. While you have many obvious towering stratovolcanoes, I personally prefer the various volcanoes, both small volcano by area. While this might not look like a volcano, it indeed is one, consisting of two small Mare explosion craters that erupted near simultaneously around the year 1050 BCE. There is a third category of Alaskan volcanoes hiding in plain sight, such as the volcano which is the subject of this video. That being shallow near coastal volcanoes which once erupted on an existing landmass when global sea levels were up to 125 meters or 410 feet lower than Addington Volcanic Field, named the Addington Volcanic Field. If we were to remove the water surface, you would easily see its most striking feature, a massive circular crater in the ground. This crater is known as a mare, a large crater measuring 4,000 feet long, 3,700 feet wide, and an impressive 953 feet deep. While we do not for sure know the age of these two cones, what we do know is the age of its large-scale central mare, which could easily fit an entire American football field inside it. Because this didn't occur after the 9700 BCE cutoff used to mark the beginning of the Holocene epoch, and the Addington Volcanic Field to the best of our current knowledge shows no signs of life at the present, it would be best to classify this volcano as not geologic setting active but instead dormant. I have to assume that the complex is monogenetic, meaning each vent only erupts once. A volcano form here in the panhandle of Alaska of all places. The area does contain other volcanoes, but with the exception of Mount Edgecombe, none of these have seemingly erupted at anything but a low rate. These regional volcanoes seem to be related to the presence of the tectonic plate boundary marked by the Queen Charlotte Fairweather. This very region experienced a cluster of eruptions between 15,000 and 12,000 years ago, decompression melting, which can be directly traced to decompression melting. During the last glacial maximum, this part of Alaska was covered by a kilometer thick of ice, which placed additional strain on underlying rock, making eruptions somewhat less frequent. However, once this ice sheet largely melted, the ancient eruption pressure required for dike propagation to begin at an underlying magma chamber significantly dropped, causing a cluster of eruptions to occur. The eruption in question was likely phreatomagmatic in nature in my analysis, although one scientific paper suggests a violent strombolian eruption, which I consider less likely. Depending on which model was correct, 15,000 to 30,000 foot high eruption plumes that largely distributed trachybasalt to tephrite ash towards the east occurred. Thanks for watching.